Hello, grade 11s. This is going to be a video series on summary of chapter 5 as requested from some of you. So this first video, I'm going to summarize lesson 1 to lesson 3. I'm going to quickly go through, all of the things. Now, I'm not going to use the textbook as a base. I will be looking at the textbook, but I will be, writing my own stuff and I'll be drawing things. And hopefully that will make things a little bit easier for you guys to follow than me just going through the textbook. So the very first thing that chapter 5 talks about in lesson 1 is we need to understand what is a function. We need to understand the zeros, the roots, and x-intercepts. So first of all, what is a function? And so to talk about a function, basically they use f of x as a notation and they have some sort of equation. So if I have a very simple equation such as 3x plus 5, this is a function, okay? And whatever I put into x, I also put in here, okay? So for example, if I put 2 into say x, if I say f of 2, it means that I have 3 of 2, 3 times 2 plus 5, and then you can calculate, it'll give you an output, and that output would be 6 plus 5, which is 11. Okay, and you can put in different inputs and outputs. Okay, so this is a function, and basically this right here, if we remember linear equations, 3x plus 5 looks something like that. That is a straight line. Okay, this is a line where we have, y equals to 3x plus 5. This is our y, this is our x, and right here we have some important information. This right here is what we call the x-intercept. In other words, it is also called the zero of the function. Or later on, we can say that it is the root of the equation. Now, in a linear equation, it's fairly easy, but most of this chapter is about quadratic equations, so we'll be looking at quadratic equations instead. So let's go straight into a quadratic equation. Let's have a look at an equation such as y is equal to x squared minus x minus 6. Now, what I'm going to do is I'm going to very quickly pull up a graphics calculator, and we'll see what this actually looks like, okay? lesson 2, 5.2 now. For lesson 2, we're going to look at something called 5.2 and 5.3. I'm going to do it together. We're going to look at something called the vertex form. Okay, and the vertex form is actually very important and very useful so that we can find particular information in a quadratic equation without having to calculate the zero, to calculate, what the maximum minimum point is, where it's located. It tells us all that information in that form. So let's take, I'm going to bring up a general form of the, sorry, not the general form, I was in like our what is the vertex form? So the vertex form basically puts a quadratic equation in the form of y equals to a bracket x minus p whole squared plus q. Okay, now 5.2, it starts exploring what q and p does. Okay, so let's have a look at that first. So we begin by looking at y equals to, let's just do x squared plus 3. And we're also going to look at what the effects is if we have y equals to x squared minus 3. So right now, I'm not looking at p, I'm not looking at a. If I just do plus 3 and minus 3, let me bring out the graphics calculator again, and we'll see what it does. okay? So let's have a look at an example. So first one, let's have a look at what if we have the equation f of x is equal to negative 2 bracket x plus 4 whole squared minus 3. Okay, so I have a left, right, a horizontal shift. I also have a vertical shift, okay, a translation. We have a stretch factor of 2, and then we also have negative, okay? So how do we describe it? First of all, we start with the ones that are, we start with the negative ones first, okay? We always describe in order this way, okay? We describe order this way, okay? Starting from the negative. So first we would say there is a there's a reflection on x axis, and then we will say there's a vertical stretch factor of 2, and then we can put the plus 4 and the minus 3 together. There is a translation of 4 units left, because it's plus 4, it's going to be left, and 3 units down because it's minus 3. So if I'm going to do a brief sketch, okay, if I'm going to very quickly sketch what it looks like without using a calculator, I know that its vertex point, that's the maximum or the minimum point, will be at 4 units left and 3 units down. So somewhere around here, that's 4 minus 4 and minus 3, and then it's reflected, so it's going to go down, and there's a stretch factor of 2, so it probably looks something like that. Let me confirm it. Let me bring up our calculator.